Welcome to Video 3C, and we're still working with triangles. We have two more topics up in this video, and the first one's called always moves when I do that right at the beginning of every video. I'm sorry. Gotta click my pen on the screen first. That would help. This one's the exterior angle theorem. Exterior, outside, angle of a triangle. Again, this whole chapter or unit is on triangles. So what this one says is, if I make a triangle, go ahead and make one. This right here is called an exterior angle. And what our theorem says is, if this is angle 2, angle 3, angle 4, and angle 1. What the exterior angle says is that the measure of the exterior angle is equal to the sum of the two non-adjacent angles. And remember from an earlier lesson that adjacent means that it shares a side. So the non-adjacent angles to angle 1 are 3 and 4. So it equals measure of angle 3 plus the measure of angle 4. Or really, the exterior equals non-adjacent. Sometimes it's easier with the words, I think, plus non-adjacent. So now let's go apply that theorem in a couple different situations. So first one, nice and easy. What's the measure of this angle? It's equal to the sum of the non-adjacent angles. So question mark will equal 35 degrees plus 95 degrees for a whopping total of 130 degrees. And I'm done. It's as easy as that. It need not be difficult. Don't make it difficult. The next one, we're going to throw, like we've been doing with all the other ones, some algebraic expressions into it. So I'm going to be looking for x. In order to find x, I'm going to grab my exterior angle, and it's equal to the sum of the non-adjacent interior angles. So 8 plus 6x is going to equal 30 degrees plus 4x plus 2. I'm going to isolate that x. I'd have 8 plus 6x. I'm going to combine my like terms on this side. I want to solve this for x. I need to get it on one side of the equal sign. So I'm going to do the opposite operation to move all my x's over onto the left-hand side. I'm going to get 8 plus 2x's, 6 of them minus 4 of them, is equal to 32. I'm going to isolate x by doing opposite operations. I'm going to subtract 8. I'm going to get 2x is equal to 32. Take away 8, which is 24. I'm going to divide both sides by 2, and I'm going to get x is equal to 12. So my answer for x is 12, and again, if they asked me for a specific angle measure, like maybe what is this angle, I would plug it in and do 4 times it and add 2. But in this one, I just wanted you to find x. On the next example, I'm looking for the measure of angle S. So let's go over here. Here's angle S. Here's its measure. Well, that means I need to figure out what 3x plus 4 is. To do that, I need to figure out what x is. So I'm going to do the theorem one more time. I'm going to say the exterior angle, 140 degrees, is equal to the sum of the two non-adjacent interior angles, which are given in the diagram. And then again, it just goes right to Algebra 1 right away. Combine like terms because they're on the same side of the equals. Combine like terms because they're on the same side of the equals. Isolate x by getting rid of what's in the way. Do the opposite operation. Opposite of addition is subtraction. I get 132 is equal to 11x. And I divide both sides by 11. And I get x is equal to, and let's do 132 divided by 11 up here. We're going to get 1, and it's 12. Again, I'm liking the number 12 today, but that's not the answer to my question. I'm supposed to figure out what's the measure of angle S. So I go up here and I substitute that in, and I'd say that the measure of angle S is equal to 3 times x, which is 12, plus 4. 3 times 12 is 36. Increased by 4 is 40. And that's the answer to my question. The measure of angle x is 40. So next topic up is triangle congruence. So I'm going to put that up there, erase some of this. And I'm going to put 2 triangles up here, and we're going to talk about a little bit of vocabulary and notation. So I'm going to put a triangle up here. I'm going to call it A, B, C. We're going to label it triangle A, B, C. Okay, and then I'm going to go tilt one over here on purpose, and I'm going to call this triangle. I don't know why it goes red sometimes. It's possessed again. We'll call this D, E, F. And suppose I told you that these triangles are congruent. What that means is all the sides and all the angles are the same measure. It's not drawn particularly to scale, but I've got 2 triangles up here, and let's suppose I put this marking here and this marking here. That means that A and D are what we call corresponding angles. So when I list this one, I've got to put D first because I'm going to write a congruence statement, and it requires that you list them in the order that they match up. And let's suppose C actually is the same measure as F. Then I have to put an F here. Oh, I lied. F would have to go at the end because that's where C is in the original. And then that would put E right here. So when I write a congruent statement, I'm going to put 3 little arcs in here. And let's go over here. A congruent statement just tells you who's congruent to who, but you have to match up corresponding parts. So I would say ABC, the triangle. Without that, it's a plane. Not an airplane, a geometric plane. Obviously. ABC is congruent to, and again, I match up these corresponding parts. D, and then B has 3, and E has 3. So I'd say E, F, and again, F, and I wrote a P. Nice. I would put a triangle in front. It says list all pairs of congruent sides. Now, I don't need to look at the picture for that. Making maximum use of the congruent statement kind of helps you answer the questions quicker because AB is first and second, so it's going to have to be the same as DE, the first and second ones listed. See what I mean? AB, DE. Next, BC is second and third letters listed in the first one, so it's going to have to be congruent to EF in the second one. I don't need the picture if I have the congruent statement. AC, first and last, will have to be congruent to DE, first and last, DF that is. All right, so that's all the pairs of congruent sides. Pairs of congruent angles, angle A is going to have to be congruent to angle D because they're listed first, or you could go back to the picture and look at their markings. Angle B is congruent to angle E, and angle C is congruent to angle F. So when you're asked to list the pairs of congruent sides, you could look at the picture, but suppose I told you that there was a pentagon and I called it PQRST, and it's a pentagon, so you'd put a picture of a pentagon in front of it, but whatever. Pentagon PQRST. I don't think you can see my pentagon because I put it out of my screen capture, so I'll go put it on here. Pentagon PQRST is congruent to pentagon WI. Let's say I don't want to repeat letters B A, F. Wyboff. Anyway, not triangle, pentagon. If I asked you what angle corresponds to angle S, 1, 2, 3, fourth letter, 1, 2, 3, fourth letter, you'd say angle A. So I would know angle S is congruent to angle A. If I said what side corresponds to PT, you would say first, last, first, last. You would say WF. And corresponding parts are congruent. So you could list it like that. You don't need a picture. You can use the statement to help you match up all those corresponding pieces. So let's go to the next page. So here I've got some pictures, and notice nothing's marked on these triangles, and I've tilted one, but again, I don't need the markings if I have the congruent statement. Again, this is called a congruent statement. So when you're doing your worksheet and it asks you to write one, don't come and ask me. We're writing it right here. Congruent statement tells you who is congruent to who. So let's go write that. Angle W, first letter, right here, would have to be congruent to angle G, first letter, right here. Now I can go mark them. So angle G, done. If I said which side is congruent to side UV, you could go try to sort it out from the picture, but sometimes when they have lots of sides and they look the same length and they just tilt it a little bit, that can be difficult. So make use of this statement. I'm doing side UV, this one and this one. So beside IH. Nice and easy. Now with the markings on it, it's kind of nice because here I'm telling you with the markings who's congruent to who. So let's write a congruent statement. Triangle, grab this one in any order, and the letter got chopped off here. Let's suppose it was an R. I'm going to just say URS is congruent to triangle. Now I have to slow down because I have to make sure when I list the letters in the second triangle that these three slots for the three letters I'm going to put in here match the order I've chosen for the first set. So let's go back to the picture. Angle W has 3 arcs in it. So I need to match it with the angle that has 3 arcs in it. Angle R has 2 arcs in it. So it has to be matched or corresponded to the one that has 2 arcs in it. And likewise, S would go with C. Again, this is called a congruence statement. And that's the end. So you can go do worksheet 3.6 and 3.7. And again, I think that one I'll have you do all of them just to get used to the notation. So you guys have a good one. And when you're done with that one, make sure everything gets checked off on your syllabus and you would be ready to take a test. You can use your notes on that test as well, so make sure they're all filled in. Have a good one, guys.